It's 1,500 operations per second. It's 1,400% rise in performance. Significant? 1,400% rise in performance. Imagine if you put this on a cluster with multiple nodes, how much performance boost you get. The magic is about the algorithm we use. It's the way we are persisting data, which is proprietary to us, right? Is the reason why we sell this. Right? The way we store data, we are able to retrieve it in a very fast fashion, also insert at a very fast fashion, update at a very fast fashion. You know, our basically data storage formula, if you take the complexity of that formula, of the algorithm, the complexity of the algorithm is completely independent of size of the data in the table. Whether you have one record or you have a billion records in the same table, the select performance, the insert performance you'll get as the same. Databases have a degradation factor, Globsity has a flat curve, absolutely flat. From an algorithmic perspective, okay, if you try it in a production environment, you will get certain degradation. It's because of system hardware degradation when you load it up, right? But the algorithm that's used is absolutely flat curve. And that's the reason we are able to give you this performance boost. If you try Cassandra and Mongo, okay, if you literally try Cassandra for something like 1,000 records, okay, it'll probably give you double operations than us, 3,000 ops per second. Okay, it will. Globsity will also give you slightly more, 1,500 can be 1,550 or something. Why? Because there's a certain amount of system degradation that happens when you increase the data. Right? But algorithmic degradation is not there, so it's about going to almost remain the same. Right? But as you load data, these other databases start degrading. And big data is all about big data. 100 million is too less. Right? You're talking about billions today. Correct? And that's where we want. We basically want you to replace your production systems. Okay, up to the extent, we give you a guarantee, you know. If you have a database that's relational, Oracle, MS SQL, MySQL, anything, right, and you want to move to another solution, you can simply plug out your Oracle database, migrate your data to Globsity, put Globsity in, remove Oracle or MS SQL or any relational database, remove their adapter, put our equivalent adapter in. No change in the application layer, absolutely no change in your code, it will work as is. That's what you want, right? It will work as is. Who wants to touch a SQL query? Tell me. Anyone seen an 8-page long SQL query? A lot of them, right? Those are write once only. There's no way you can change them, right? Absolutely no way you're changing them. That's what you want. You want those queries to work, because if you want to transit to another solution in a big data and it requires rewriting everything, it doesn't have SQL support, that's it. It's dead end, right? You can't start changing everything. And that was the main motive behind developing this, that we need systems for migrating to distributed architectures, right, from relational models, while at the same time supporting all relational models. So let me go and talk about a case study, like a real-time implementation, right? You all want to know where this is being used, yes? Absolutely not. It will run on Linux, Mac, Windows, anything. Commodity hardware. There's no restriction or limitation at all. Yes? It was 10 KB per. Oh, that was around. It was around 800 GB or something. Yes, kind of. Globsity will consume slightly more data on the hard disk than other databases because of the solution that the way we index our data will slightly consume more, but it's hardly like 20% more than relational models. Okay, so if you compare it to if you have 1 million records in Oracle and 1 million records in Globsity, Globsity storage will consume 20% more than Oracle. And as far as the other database is concerned, it will be slightly more in terms of raw data, but if you consider indexing, the index sizes of Globsity are actually far lesser than something like Mongo and all. Like when I index this data, it consumes size which is less than KBs. okay, because we leverage file system capabilities of indexing directly into the database, right? So we know exactly at what blocks on the file system the data exists. And we know the pointers to those blocks rather than pointers to a file, so it's done at a very lower level. Right? And because of which we do not require to store huge amount of index data on your storage. So when you talk about indexing many columns, which is what most big data applications do, right, your index sizes in Velocity are very less. Okay. Yes, absolutely. Absolutely. Changing is all permitted, so you can do all types of changes, you can do trigger changes, you can do filter changes at runtime in production, even while the system is taking transactions. Okay, and it doesn't have implication on performance, right? Your complexity of your filter function can have implication on performance, right? Which is on the code you have written within the filter, which if that is not optimized, you will not get that performance that you want, right? But that's completely in your control. Right, but usually when you take a subscription from us, our architects make sure you're doing the right implementation to get the best performance from the system. Right? Yes, absolutely. It's consistent write performance. Absolutely. It'll be, again, it's the same thing. It'll be slightly lesser than something like Cassandra and Mongo initially. When the data increases, Velocity will still be consistent in writes. Other databases will go far lesser than us. Can we do one thing? Can I just complete the presentation? I have just 2 or 3 slides left, and then we keep questions for the last. Is that fine? Yeah, and then we are following with a tea break. So we have a table at the back. I can always answer them there. Yeah, perfect. Okay, so let me talk about this actual real-life implementation, okay, of this database. That's what we want to know, right? So UL, you all know UL? Underwriters Laboratories. Do you all know it? Yeah? How many don't know? Okay, I bet you all know it. I seriously bet you all know it. Okay, you just got to open your cell phones, check the battery, you will see this logo on it. Okay, right? You all know it. They basically do safety certifications. Okay, so what UL had was they had data for fire incidents that have happened across whole of United States of America for the last several years. Okay, and they wanted this data to be searchable at real time. Okay, the data was ranging to something like millions of, about 3 to 5 million records per year, each record having 300 plus columns. All columns required indexing. Okay, now a relational system cannot index 300 columns. Maximum you can index is 256. Right? We were able to give them indexing for all 300 columns. 300 plus, it's more than 300. Right? Now what they want is, they want this data to be searchable across several factors. Okay? And it's usable by insurance companies. So they give this data to insurance companies to basically run searches on this data to identify patterns, right, of fire incidents that have happened in a particular region. Say classified by state, classified by family dwelling, right, what type of household it is, how many people stay in the household, whether it's fire certified, it's safe, what type of material is used, right? So they can basically search on various criteria, even get the performance of fire stations nearby, and then set an insurance premium for that particular location, okay? So what we are talking about, let's see, I'll show you a quick demo, okay, of how this works and how fast our database can search through it. So what is the data size that we are talking of, right? It is 3 to 5 million records per year. Today they have more than 10 to 12 years of data. Okay, that's almost 50 million plus data points. Each record has 300 plus columns. If you do simple math, you land up with 15 billion searchable data points. All indexed, all columns indexed, all rows indexed. Okay, and I want you to see what performance we give. This is all hosted on our cloud as of today. Video is captured from a cloud environment. So the insurance agent comes, he basically does a selection of items he wants. So he chooses state as Alabama and Alaska, chooses property use as 1 or 2 family dwelling, very simple search, you have the result. Instant. Search through 50 billion points. You can see how many columns are there, right? These are all columns, values pertaining to independent data points. And it identified all the data points instantly that mapped the search criteria. Instantly. This is in production for the last 1.5 years, running on our servers without any flaws. We're able to service all their customers at real time, near instant. If you look at this particular thing probably took 2 seconds to load. If you look at the database response time is 300 milliseconds. Okay, the rest of the time is actually to render that much amount of data on the page. Okay, you can actually see it. You will see it. If I go back, I play it again, you can see it's choosing the fire department state, Alabama, Alaska. Property use is 1 or 2 family dwelling. Very simple search. Hit the submit button. Result is already there. Now the page went blank. It's loading the page. Right? And you have your data. That is true performance. This is a fully relational system. Used with an ORM. There's no querying mechanism happening. Okay, you just have to populate your search. Instantly gives you the result. So to summarize, what are the key benefits? Right? We offer no latency overhead because there's no TCP channels in between, right? There's reduced failure probability. Why? Because we are having less blocks, correct? So the application and database is combined together. Less of the blocks, the less of the failure, right? In which case is your application actually usable if your database fails? Or your database is usable if your application fails? Absolutely not, right? Correct? You need both of them up, correct? And since both are combined, either both are running or both have failed. There's no point anyways having one up. Correct? You have more throughput. More throughput, why? Because of 2 reasons. One is no query, which gives you a performance boost. Other is the algorithm we use. So our algorithm itself is giving you a throughput of 1,400% better than other databases. Right? If you use the same thing in no query mode, you'll get 233% more operations per second over and above the 1,400%. Right? Then we have fixed time insert, select, update, and delete. That's the algorithm. It doesn't have any relation with the amount of data in the table. Right? It's going to take the same time to insert, select, update, and delete the first record as it would take the billionth record. That's the only way we can give you such fantastic search performance. Otherwise, it's not possible. Right? We have proprietary indexing algorithm. So you have support for B-tree, hashed, and it's designed in a particular fashion to give you fancy algorithms for false point eliminations, okay, which quite a few databases use. We have used it in a specific pattern, which allows us to search faster through the data. Then you have schema change support. Right? I'll only take 2 minutes. We have schema change support. Right? So our systems you can apply a schema change on the live system, right? Which SQL systems had that ability. NoSQL did not have that ability. Some of them do have, some of them do not have. Right? But after all, everyone realizes we have to change schema. Right? At some point in time, you're going to have to add column, remove a column, or change the data type of a column to the bare minimum. Right? Now, it was all fine when it was SQL. Right? 1 million records, schema change you want to do. You keep your system off for 5 minutes, so it'll apply the change. Sometimes even half an hour, it'll apply the change. You're in production after that. Big data, billions of records. If you want to apply a schema change, that's the end. Your production is down for 2 weeks. Unacceptable, right? Schema changes in Blob City are fixed time operations. They execute in 1 time unit cycle. That's basically milliseconds. It doesn't apply the change on all the records. That's kind of crazy. You can never do that in a big data deployment. But it keeps track of what change you apply. So next time you fetch the record, it will ensure that you get a record with the changed schema. Correct? Consistency is there. You insert a record or you update it, it will always insert or update with the change schema. So you don't have to wait. You can actually perform a schema change while there are transactions happening live on the system. Okay, we can literally show you 500 clients doing transactions on the database at real time, and you change the schema of a column, no impact. Everything is successful, no failures, absolutely at all. Okay, then triggers give you the ability to create relationships. Also, they are much more capable, not just relationships. Right? Classic example of a trigger can be you. Anyone has worked with time series data? When data comes with timestamps? Yes, right? Timestamps are non-indexable. Everyone knows there's no point indexing a timestamp, right? It's the most useless thing to do, correct? But a trigger can actually help you split this timestamp during an insert operation into DD, MM, YYY. Now suddenly, splitting that into DD, MM, YYY makes much more meaning out of that whole data. Because now I can search which all incident happened on the first day of a month, what all happened in a given month, what all happened in a particular year, or what all happened on 31st December of any year during New Year celebrations. Right? That's what a trigger can do. It's not just used for relations, it's used for much more. Then you have filters that can do complex scan jobs. So you've worked on geospatial data. Everyone has, right? You have latitude, longitudes. Now you want to perform, say, a distance computation. You want to get all the restaurants from this position which are less than 1 kilometer. How will you process this? You're going to pick up all the data, start searching through it, and then give the result set. Right now, if there are billions of restaurants in the world, there's no way you can pick up billions of records, process, and give in real time. That's when you write a filter. So you write your distance computation formula, which is a standard one, apparently, into the filter. Allow it to do that computation, give you the response. Comes instantly. Right? So you can see the power of it. Right? So that's about it. Okay? And that's my contact ID. Apparently, my business card is also attached on all brochures that you have. So feel free to write to me. In case we do not get time to, because it's like almost towards the end of the day, we have a few sessions after this. Right? And we'll be leaving early. We're based out of Mumbai. So we're flying back to Mumbai. In case we cannot connect, I would request you, on our table, we have a small bowl. You can probably just drop your business card and we'll get in touch with you later as well. So if you want a full demo of Globcity, we'll arrange it for you. Or you can simply go to our website, register, one of our consultants will get in touch with you. Do we have time for questions? Or?
Sure.
Yeah. They're not openly shared, but I can send you a whole sheet. Yeah. Pretty much. Pretty much. I'll tell you, see, there's no reason why you would use this for a small size database, right? But other than, it will work. Not that it won't work, right? Because for all our clients, most of them, quite a few we have started their applications itself from Globcity. So the first record that went in was into Globcity, right? And we advise this, why? Because when you're designing a system, it's a lot of effort in designing, right? 5 years later, you don't want to realize that my data has grown so much that it doesn't perform and now I have to migrate, because migration is very expensive, right? So just take the precautionary measures. The database will work in small records. Absolutely. But if the data size is small, the lesser performance has really no impact on your system.
A very basic question, but you said application and data, there is no TCP in between. So when the same data is used across application, how do you handle?
Then you have to, across application mean?
Yeah, always the data is same, but you are using it across application. That's how the
Oh, that's fine. So the database is exposed to both your applications. Each application communicates with the same database instance without TCP channels. Okay. You can have a single database instance, but multiple applications communicating with it, which is what most of our clients do that. So you don't usually, applications are not single modules, right? You have multiple modules,
right,
which are interacting with the data. All those modules operate in no query mode.
Okay, that is without, all those applications operates without TCP,
yes,
right?
Absolutely. We do give an evaluation, okay, so, but we give it on a one-on-one basis. So it's not freely available directly. If you write to us and you tell us a specific use case why you want to test it, we give it to you. But it's available for purchase. Right? Obviously, we don't want you to purchase, so we encourage evaluation. All our customers are paying us. We have told them, you try it for a month or 2 months, right? Evaluate it. We weren't initially giving evaluation for on-premise. We are even doing that. On the cloud, it's free. So you can use it on the cloud for 500 MB, permanently free. Okay, no limitation at all. You can try everything you want on the cloud. Right? For evaluation, we can give you a download. You can try it. No issues with that at all. Sorry, I can't hear you.
Getting the mic. The first question is when did the first stable version, when was that released?
It was basically 2 years ago.
Okay.
So from 2 years, we are having the system in production, but we never started marketing because we wanted to be sure that it was there. Okay, and that's kind of the major release that we did 2 years ago. It's pretty much stable. We did feature additions to it, okay, for certain things like building an admin panel and other services that were there outside, not the database core logic. That's been stable and not touched for almost 2 years now. And we started heavy marketing like last 6 months. For the last 6 months, we are heavily marketing this.
Okay.
Before that, we weren't marketing. It was with a close set of customers. Okay, so we wanted to be sure that our database performs very well in production. Now we have use cases, right?
Sure.
But it's working fine. Our customers are happy. We say, okay, now it's time to take it to everyone.
The second question is in terms of the deployment architecture. I think you highlighted that you can take out that TCP connectivity to the database itself, right? So does it mean that this database engine is deployed inside the application container itself?
If you have to use it in, yes, that's a good question.
That's not the typical that's not the typical deployment model, but that's an option. Is that what you said?
Yes, absolutely. If you want to leverage the no query performance boost,
okay,
right, that's 233% over and above the 1,400%, then the application and the database has to be on the same machine. Okay, but both application and database will be clustered. So you're not talking about a single unit. Okay, everything goes in a whole cluster, Java EE clustered environment. But if you want to have your database nodes separate than your application nodes, which quite a few of our clients do, they still get the 1,400% benefit, right? And benefits of SQL and relational data models, which other big data solutions don't get. They get all those benefits, and you can still deploy. So it's 100% backward compatible. So you can use it over ODBC, JDBC, that's not a problem.
Thank you.
Yeah. It means, see, basically to connect to a relational, basically for your application to connect to a relational, the two things you're doing. One is you're following an ODBC or JDBC protocol, right? And the second thing you're doing is writing SQL.